All right, so what we have covered up to our third session, that means last Monday session, right? So we have initially we have talked about, like, we have given a brief introduction to data science. Then we have talked mainly started to talk about the first portion of the data science, like how you're gonna massage the data which can be applied for analytical algorithms. So that's what the process we called as data wrangling, right? So basically preparing your raw data where it can be applicable or where it can be suited for the data science algorithm or data mining algorithms, right? So this is a very time consuming task. Usually in data science processes, like 60 to 70% time will be allocated to data wrangling or data preparation part. Then we have discussed about two main steps of data wrangling, right? So we have divided data wrangling process into, so this is kind of a, so there are many ways, like people can divide data wrangling into different stages, right? But here's a kind of a acceptable and like my version of data wrangling steps. Like there are two major steps, like data wrangling. If you talked about data wrangling, so you can, first step will be the data cleaning process, right? The second stage will be the data pre-process. Once you clean the data, then most probably you will have the nice tabular format after you clean, right? So all the variables are represented in columns and all the observations are represented in rows, right? So likewise, you have the nice structured format data once you clean the data. After you clean the data, that means like when you have the structured format, then you can do the further pre-processing data, right? So those are the two major steps that you will see in most of the data wrangling textbooks or data wrangling domain. And so then we have talked about what are the major tasks of data cleaning, right? So first task will be the tidy in the messy data. So tidy in means we're gonna build our data structures where each variable represent a column, each row represent an observation, right? So that table forms the observational unit, right? So if you can somehow make that type of data, right? So that type of data we call as the tidy data. All the other formats of data we call as messy data, right? So we on second session onwards, like we up to last session, we have talked about what are the different ways or what are the different strategies, different Python libraries that we can convert the messy data into tidy data, right? So today, the first thing that we are going to look at is how to remove the missing value. So we have started with the data set, right, on last week. So we will continue that one and we will continue those other data pre-processing tasks. Then we will data cleaning tasks. If we have time, then we can move on to the data pre-processing, right? That's what we are going to do in today's session, right? So go ahead and open up your Anaconda Studio and Jupyter Lab, right? So I hope you all can see my slides, not slides, so my Google Chrome tab, like Jupyter Notebook, right? So this is the place there that where we have stopped on last session. Right, so today we are going to talk about how we can handle the missing values, and then we're going to talk about how we can handle the outliers. Right, so those stuff we are going to talk about today. And so we have, I just, I'm going to use the sample data, sample.csv file. So basically it containing 10 rows, like, so here I just display the data frame, right? So you can see, like, by just looking at this entire data frame, you can see there are two missing values. One is in age on 7th row and one is on salary 5th row, right? So we'll do the outlier, sorry, missing value analysis, like using this sample data set, right? So this can be applicable for any larger data set. So I'm just taking this small data set so we can inspect it quickly, right? So if you want to find out is there any missing values, right? So what you can do, you can use the isNA function, right? So it will check with the, so df.isNA, it will check with the, is there any missing values in my entire data frame, right? So if there's a legal value in that place, so then this function will return the false. Otherwise, all the missing values, like, is there any missing values, NA values? So that place, it will return as true, right? So that is the base function that we are going to use it. But if you think about, like, so if you have a larger data set, like, so right now in data science, we are not talking about this kind of a small data set. For larger data set, displaying this value is not going to be useful, right? So what we are going to do, we are going to somehow summarize this function output, right? So df.isNA, so this will give us the summary of that isNA function. So now you can see for each column where how many missing values are there. So country does not have any missing values. Salary does not have any missing values. So age have one, salary has one, purchase has zero, purchase doesn't have missing value. So that's how you can find out. You can summarize the is in a function to quickly get how many missing values are in your data set. So go ahead and execute those lines and get the same answer, right? So you should get the same answer for this case. All right, so hope you all have completed up to this point. So this is the way how you can find out is there any missing values in your data frame, right? So what will be the easiest way to get rid of missing values, right? So what will be the easiest way to get rid of missing values? Like if you have a large data set, maybe like 1 million records, and if you have maybe like uh, about like 10 to 20 missing values, the easiest way that you can do, you can drop the missing values, like drop the rows that contain in the missing values. So because that doesn't, yes, so the easiest way, so I'll answer that question, right? So what is the easiest way that you can do the missing values, handle the missing values if you have large number of records, right? So you can easily drop the rows that contain in the missing value. So if you have 1 million records, it does not matter. It's not going to be that much significant to drop the 5 or 6 or maybe even 100 records from one out of 1 million records, right? So there's a question like, uh, what is the like is null? So is null also it will return this same thing, right? So is null function or can be used for to find the missing values, right? So there's not that much difference because is na is like not applicable or nan values, or is null also it's looking for a null values, right? So this both can be used to find out the missing values. In why I have explained is a function, because most of the times like uh, in data science domain, null missing values are represented in NA or the not applicable tag, right? So that is why is NA will be like more, your code will be more readable like than the is null one, but essentially it will give the same output is null and is NA function. So I hope that answered the question, right? So then we will go over what we have talked about, like the easiest way that you can handle the missing values. So if I look at my data frame, so I have missing values in my fifth row and seventh row, right? So row numbers starting from 0, right? Fifth row and seventh row. So what is the easiest way? If you have if you are, can if your data set has large number of records, then you can easily drop the missing values, like drop the rows which contain in the missing values, right? So how you can drop it, like sorry, I before I'm dropping it, so I'll let me, so I'm going to copy my original data frame, because otherwise if I drop it, my, so this is how you can make a copy of your data frame. So df copy contain the exact same data frame, right? So why I am copying it, like if I remove those rows from my entire data frame, so then if I have to show you other missing value handling cases, like then I have to reload my data frame from the CSV file. So instead of doing that, so I'm just making a copy of my data frame, right? So this is how you can make a copy of your Python data frame, right? So from my DF copy, I'm going to drop the drop NA values, right? This will be 0 because I want to drop it in row wise. So I'm going to replace. I'm not going to keep those empty rows, right? So now if I look at the DF copy, now you can see it does not have those two missing value rows, right? So that is how you can drop the missing value. So that is the one way and easiest way of dropping the missing values or removing the missing values, right? You just directly delete in the rows containing the missing values. But this method is not recommended when you have a small number of records and when you have large number of missing values in that records, right? All right, so hope you all have completed up to this point. So is there anyone who's still working on this, removing the missing value rows? So these are very easy command. Maybe you have already familiar with this command, right? All right, seems like you all have completed, right? So removing the rows that contain the missing value might not be the efficient approach, or they might not be the optimal approach when you have a small number of records or when you have large number of missing values, because then you will lost significant amount of records from your data set, right? So that is not a highly recommended way. But if you have large data set and if you have a comparatively small set of uh, rows containing the missing values, then you can easily delete, because that is not going to be a significant amount of your data frame. But see, if you consider about this data set, this sample CSV file, that DF data frame, right? So it containing only 10 10 rows. So if you drop the rows that contain in the missing values, you will end up with 8 rows. So that will be very few number of records. So if you do not want to drop the missing value rows, so what you can do, so we can impute the missing values, right? So that means we can give some value to these missing value places, right? Maybe we can assign a 0 to there, maybe we can assign maybe column average to there, right? So that in that way, we don't have to drop the rows that contain in the missing values. We do not, then if you somehow impute the missing values, then we can keep those rows within our data frame and we can do our analysis, right? So that is what we're going to look at it now, right? So how we can like impute the missing values. So first of all, what I'm going to do, let's say mean of, I'm going to calculate the mean of age. So this is how you can calculate the mean of age. So I'm going to calculate with the original data frame, age column. So what I'm going to do right now, I'm going to replace my missing values using the average of that column values, right? So I'm taking the mean value of the age value right now, right? So that column average. So what I'm going to do next, I'm going to replace that column missing values with my column average, right? So this is a kind of standard way how you going to impute the missing values, or maybe sometimes you can impute with the missing values with 0 or impute with the mode, right? So there are different ways how you can impute this, but in this scenario, I have choose to impute my missing values using the column average or the column mean. All right, so then now we're going to replace the missing values, column age, df age equal to df age. So there's a pandas function or the data frame function fill in a. So what is the value that you're gonna fill with it, right? So I'm going to say mean age, right? So this is the value I'm going to fill it. Right now, if I look at my data frame, now you can see, so my seventh column missing value is replaced with that column average, 38.778, right? Hope you will have. So this is kind of a easy stuff. So all right. So hope you will have completed up to this point. Now you can see like, so what is the problem here? Like previously age is like just, it's like whole number. So I have introduced 38.77, right? So what I can do, I can apply this one to round. See, so now I can replace it with it. Okay, so I have replaced it with previous one. Where's the, anyway, so this is the how we'll do the rounding in for the next, for next one. Actually we don't have to do, because right now it doesn't have the age column missing value, so that's why it does not replace this 38.77, right? So if you want, you can replace these missing values in one go. So I'm going to remove the missing values of salary. So this will remove your missing values in your salary column. So right now you can see, so I have replaced the missing values using my salary column in just in a one statement. Or, all right. So hope you will have completed up to this point. If you have any question, please raise on the chat, or you can turn on your mic and ask any questions. And so now we have this, that is the one way, like, so there are certainly other ways that you can handle the missing values. Probably you'll know like better ways to handle in the missing values. So this is the general way of handling the missing values. Right. So next, for the next one, so what I'm going to do, I'm going to share a new data set. So I'm not sure whether I did not share that file. All right. So in this chat, I have shared with you all a one data file called concrete.csv file. So go ahead and download that file and copy it into your data folder, that our common data folder for Jupyter Notebook. So this is the concrete data file that we are going to look in, right? So let me, so right now using this concrete.csv file, we are going to look at how we can handle the outliers, right? So that is our next topic in data cleaning, right? So we have make messy data into tidy data. Now we have removed the missing values. The next one is we want to look at, is there any outliers in our data set or not? If there is any outliers, we're going to handle those outliers, right? So that is what we're going to do it. So in order to do that, we're going to use the concrete.csv file, right? So this has thousand, I guess it has 1030 records, right? So for it measures the strength of a given concrete based on some other independent variables, right? So first of all, we load this data set. So now what we are going to do, we are going to handle the outliers. First, we are going to import the data set. So I'm going to go concrete. So my data frame name will be concrete. So I'm going to use pd.readcsv. So I have stored in there. So if I look at the concrete head, so go ahead and load the concrete.csv file into your Jupyter notebook. So if you want to look at what is the size of this data frame, like you can, so you can see it has 1030 records in 9 columns, right? So I'll take a one column and I'll show you how to handle the outliers, right? So maybe in your statistic courses, like you have learned how to handle the outliers. So I'm just explaining one standard way. Like if you want, like you can go with more advanced statistical methodologies to handling the outliers, right? So I just explained the basic way of handling the outliers in here. All right, so let me first of all, like how do we identify whether there's an outlier or not, right? So the easiest way is to identify whether there's an outlier or not, like by plotting the box plot, right? So what we are going to do, so in order to plot the box plots, I'm gonna import the, so let me explain what I have done it here. So here what I have done, like, so the easiest way that you can find out whether there's an outlier for a given variable or not by just drawing the box plot, right? So if you remember, like if you draw the box plot, right? So if you have the like lower end and the upper end, right? So if you see any kind of a data points below and upper the upper edges, like then usually you'll call those points as outliers, right? So most of the scenarios, right, that might, so there are other more statistical sound ways to you can find out the outliers, but we will go with the simple interpretation and we'll handle the outliers using the basic method, right? So if you want, you can find out the other ways of handling the outliers. So there are some books like, especially they are talking about like outlier detection and anomaly detection, right? So this is kind of a whole new domain, that how we can handle or how we can find out the outliers. But here we are going to explain one basic way, right? So that is, so what I have done in cell number 31, like I have imported the relevant library to plot my box plot, right? So that is what I have import. So the first line, I have import my matplotlib.pyplot as the plt, right? So that will be the aliases for my matplotlib.pyplot, right? Then I'm telling I want to plot. I don't want to open it up a new window or anything. I just want to plot everything within this inline text, right? So that is why I'm specifying this parameter matplotlib draw everything within the inline or within the notebook, right? So that is what I have done in these two commands in cell number 31, right? So let's draw the box plot for, let's draw it for the water variable in my concrete data frame, right? So let's say plt box plot. So I'm going to draw it for concrete. Then plt dot show. So this has to be, so I'm going to and so this is how you can draw the box plot in Python. So this is the first graph, I guess, we have drawn in Jupyter notebook, right? All right, so hope you all have completed up to this point. So is there any, if there are any questions, please let me know through chat or turn on your mic. right? So now by looking at this block spot, right? So you can see like in box plot, after upper tail you have 2 points, and below the lower tail you have 1 point. So usually, like in some domain, in this case, we'll label these points as outliers, right? So how this box plot is drawing, like the lower end of this box plot is like your Q1, right? Quantile one, 20, 25%. Then you have the at the center you have the median. So this one is the mode, right? And then you have the Q3, right? So these two tails are drawn at 1.5 times Q3. This tail is drawn, right? And this lower tail is drawn from 1.5 times 1.5 times interquartile range, right? So this is how the this tail is ended. So if you have any points up above the 1.5 times interquartile range and below the 1.5 time interquartile range will be displayed as the separate data points. All right, so there's one question like, what is the uh, meaning of this one, like matplotlib inline? So here the first command I have import the matplotlib pypot library. Here this command is giving just a Python compiler to or Python interpreter to just when you're uh, drawing the graphic, do not open a do not put it in anywhere else, like do not open any window or anything, just display all the graphics that you're using within my notebook. So that is what this command is meaning. Use that matplotlib library within the inline. Inline means within this textbook. So then we can draw or we can show all the graphics that we are producing using the matplotlib library within our notebook, right? So that is the main idea of putting that this highlighted line in the cell number 33, right? All right. So what I was doing is I was interpreting this box plot, right? So this is the box plot for like the water column in our data set, right? So how we can interpret this one, like this box, right? So this box is drawing from uh, this was drawn from Q1 to Q3, right? So this line is showing the mode of your data set, right? And the lower tick is drawn from this point to 1.5 time interquartile range. And similarly, from Q3 to 1.5 times interquartile range, this upper tail was drawn, right? So then usually what we're going to tell or what we are going to label, though, if any point above this tail and any point below this tail, we're going to label as an outliers, right? So in this case, we will have few outliers. So if you zoom it, maybe like it might will have more outliers, right? So right now it representing only 3 points, but it does not mean like we have only three outliers. So sometimes these points might be on top of each other, right? So that's why we feel like three. So we will see how many actual data points are there once we remove the outliers, right? So now this is one standard way with the uh, this is the standard way how you can find out whether any variable containing any outliers or not, right? So now we'll see, okay, now we'll assume that uh, let's see. let's try to. So if you want to get the let's say quantile one q1, right? So I'm going to handle the q1, right? So sorry, outliers, concrete q1. Let's say here. So, so this will give you the quantile for each variable in your data set. But right now we just want to handle the outliers in water column, so we can just take it that column uh, q1, right? So but I have taken as like all the columns q1. Like if you similarly, if you want that, you can find out the q3, q2 will be the average, right? So that's, so where I'm heading, like I'm trying to remove these outliers in from my water column. So in order to find out my remove the outliers, so I want to find out the q1, q3, and the interquartile average. So that is where I'm trying to find out. So this lower tick is drawn from the from q1 to 1.5 time interquartile. So what I'm trying to do is I'm going to remove any points below this 1.5 times interquartile range. I'm going to label it as outliers, and I'm going to remove those points from my data set, right? So that's the easy fix. Otherwise, you can replace these points with some other value or something like that. So that is what even we have done for the missing values. So I just, for the simplicity, I'll remove those points, right? So that will be a easy fix, right? So now I have calculated the q1 and q3 for entire data frame. So now I can calculate the interquartile range. Interquartile range iq3 yes. So this will give you the entire data frame for each variable. What is the interquartile range? So now, right now we are trying to remove the outlier based on the interquartile range. We are going to remove the outliers based on our water interquartile range, right? All right, so I hope everyone has calculated the interquartile range. All right, so I hope you have calculated the interquartile range for each variable. So right now we are trying to remove the outliers based on the water column, right? So we will see how we can remove the outliers, right? So this is the easy fix, right? So this is a one way of handling the outliers, right? So you know how to right now in visually find out outliers, whether there is an outlier in a column or not, right? Now what we are going to do, we are going to remove the outliers. So let's see. uh, from concrete. I'm going to remove the, so how I'm going to remove the data points. So I'm going to check concrete, water. If value is, this value is less than Q1 minus 1.5 times quartile range. Okay, so let me explain what I have done it here. And so I'm checking.